When dealing with electrical conduit repairs, especially in critical applications like circuits powering tower cranes, it's essential to adhere strictly to the National Electrical Code, or NEC. The NEC sets the standard for safe electrical installations, and its guidelines must be followed to ensure the integrity and safety of electrical systems. In the specific scenario of a conduit run 4 feet below grade, where a plumbing subcontractor damaged a 3-inch conduit by breaking off a 2-inch square piece during gas line excavation, the question arises about acceptable repair methods besides replacing the damaged section. According to the NEC, any repair made to a conduit must provide equal or better strength than the original conduit. This requirement is not just a matter of code compliance, it's about maintaining the structural integrity of the raceway system, protecting the conductors within, and preventing potential hazards. Therefore, the seemingly straightforward answer, but the most effective and compliant solution, is to replace the damaged section of the 3-inch conduit. There are several reasons why simply patching or attempting to reinforce the damaged area is generally not acceptable under the NEC. Firstly, the structural integrity of the conduit is compromised. A 2-inch square piece broken off represents a significant weakening of the conduit wall. Any attempt to patch or reinforce this area might not restore the original strength, making the conduit vulnerable to further damage from soil pressure, ground movement, or accidental impacts. Secondly, the NEC requires that all electrical work, including repairs, be performed in a neat and workmanlike manner. This means that the repair should not only be functional but also visually acceptable and durable. A patched or reinforced section might not meet this standard, especially if it appears makeshift or prone to failure. Thirdly, the presence of a patch or reinforcement could create a point of weakness in the system. This weakness could lead to future problems such as water ingress, corrosion, or even physical damage to the conductors inside the conduit. These issues can compromise the safety and reliability of the entire electrical circuit. When a conduit is damaged, several factors come into play in determining the appropriate repair method. These factors include the type of conduit, the extent of the damage, and the specific requirements of the NEC. For example, rigid metal conduit, or RMC, which is commonly used for underground applications due to its strength and durability, requires a different approach than electrical metallic tubing, or IMT, which is typically used in dry, indoor locations. The NEC provides detailed guidelines for conduit installations, including requirements for conduit support, bending, and joining. These guidelines are designed to ensure that the conduit system is mechanically sound and provides adequate protection for the conductors. In the case of underground conduits, the NEC also addresses issues such as corrosion protection and burial depth. Underground conduits are typically subject to more corrosive environments than those installed indoors. Therefore, they often require special coatings or materials to prevent corrosion and ensure long-term reliability. The NEC specifies minimum burial depths for underground conduits to protect them from physical damage. These depths vary depending on the type of conduit and the presence of vehicular traffic. When a conduit is damaged, it's essential to assess the extent of the damage carefully. A small dent or scratch might not require immediate repair, but a significant break or puncture, as in the case described, necessitates prompt action. The NEC requires that damaged conduits be repaired or replaced to maintain the integrity of the electrical system. In some cases, it might be possible to repair a conduit by using a listed fitting or coupling. However, these fittings are typically designed for minor repairs, such as sealing a small hole or reinforcing a weak spot. They are not intended for major structural repairs, such as replacing a large section of damaged conduit. Therefore, when a significant portion of the conduit is damaged, replacement is generally the only acceptable solution. Replacing a section of conduit involves several steps. Firstly, the power to the circuit must be turned off to ensure safety. Secondly, the damaged section of conduit must be cut out and removed. Thirdly, a new section of conduit must be installed, using appropriate fittings and couplings. Fourthly, the new section must be properly supported and secured. Fifthly, the conductors must be carefully pulled through the new section of conduit. Sixthly, The connections must be made and tested to ensure proper operation. Throughout the repair process, it's important to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and using insulated tools. It's also important to ensure that the work area is properly ventilated to prevent the accumulation of hazardous fumes. In addition to the NEC, local codes and regulations might also apply to conduit repairs. These codes might have more stringent requirements than the NEC, so it's important to check with the local authorities to ensure compliance. For example, some jurisdictions might require that all electrical work be performed by a licensed electrician. Others might require that a permit be obtained before starting any electrical work. The consequences of failing to comply with the NEC and local codes can be significant. In addition to potential fines and penalties, non-compliance can also lead to safety hazards such as electrical shocks, fires, and equipment damage. Therefore, it's essential to take conduit repair seriously and to ensure that all work is performed in accordance with applicable codes and regulations. When in doubt, it's always best to consult with a qualified electrician or electrical inspector. These professionals can provide expert advice and guidance on the proper methods for repairing or replacing damaged conduits. They can also help ensure that the work is performed safely and in compliance with all applicable codes and regulations. In this specific case of the tower crane circuit, the importance of proper conduit repair is even greater. Tower cranes are critical pieces of equipment on construction sites, and their safe and reliable operation is essential. A failure in the electrical circuit powering the crane could have serious consequences, including equipment damage, injuries, and even fatalities. Therefore, it's essential to ensure that the conduit system powering the crane is properly maintained and repaired. This includes using only approved materials and methods, following all the applicable codes and regulations, and performing regular inspections to identify and address potential problems. In summary, when dealing with damaged conduits, especially in critical applications like tower crane circuits, the most prudent and code-compliant approach is to replace the damaged section. Patching or reinforcing the conduit might seem like a quick or cheaper solution, but it typically does not provide the same level of strength and reliability as a replacement. By following the NEC guidelines and using appropriate materials and methods, you can ensure that the conduit system is properly repaired and that the electrical circuit is safe and reliable. Therefore, in the given scenario, replacing the damaged section of the 3-inch conduit is the only acceptable form of repair according to the NEC. This ensures the integrity of the electrical system and the safety of the equipment and personnel involved.